Boom. There we go. Hello and welcome to Statistics. Generate random numbers using your calculators or Excel or Minitab, various different software out there to get these numbers. Now, we also have other techniques which are outlined in this section. So we'll start with systematic random sampling. These are procedures which you learn, and then you take samples, right, using that technique. Now let's take a look. So the first one is, I changed the color here. So procedure for systematic random sampling. So we have 3 steps. So divide the population size by the sample size and round the result down to the nearest whole number, and we call that number m. So step 1, divide population by sample size and round down to nearest whole number. And we are going to call step 1 m. So that's going to be our variable m that we're going to look at. Now, step 2. Use a random number table or a similar device to obtain a number k between 1 and m. So use a random number table. That was the last class, the big table that we looked at. Or whatever else. Actually, or I'll just put software. That's easiest because we are here. To obtain k, to obtain number k between 1 and m. So 1 less than k less than m. So we have to find a number. So if m turns out to be 29, then k has to be somewhere between 1 and 29. And then finally, step 3. Select the sample. Select for the sample those members of the population that are numbered as k, k plus m, k plus 2m, and so on. So select for the sample those members of the population that are numbered and this is now the formula. So pick k, then you have k plus m, which brings you to the next batch, then k plus 2m. What is the next one? K plus 3m, and you can go as far as you need to. So this is a procedure, and we're going to take a look at the example of this. So, all right, sampling student opinions. Recall example 1.8 in which Professor Hassett, fine, wanted to sample 50, a sample of 15 of 728 students enrolled in the college algebra at his school. So to deal with this, we have, so here, example, population, which is all students enrolled in algebra, is 728. We want sample size 15. And we can use the method that we just outlined. So let me just check, is this, okay, great, it's moving, so everything is good. No, this one. What do we do? So step number 1 says that you are supposed to divide population size by sample size and round down to the nearest whole number. So this calculation for everyone, right, is use your cell phones, calculators, whatever. It's going to be 728 divided by 15. So for step 1, we have 728 divided by 15 to give us 48.5333 forever. So the m that we need to get from the first one is 48. You have to round down. So we are not going to look and say, okay, it's 0.5 or 0.6 rounds up. It's always rounding down in this method. To round down to there is a mathematical function called the floor function that does this, but they didn't want to go into details of exactly what is the mathematical thing we use. So that's what we have. So m is equal to 48. Now, in step 2, generate random random k such that 1 less than k less than 48. The number which all right, I'm not sure what we missed, but definitely the projector is not working. Let's calculate the numbers. You can my numbers are, since the k is 9, the next number is 9 plus 48, which is 57. And then 2 times 48 is 96. 96 plus 9 is 105. Now we're going to actually find all of these. So what do I have? So it's a 48 times 3 now. 144 and 9 is 153. Remember, my sample has to have 15 numbers. 201. 249. 297. 345. And we go, so every time I go, it's 48 times 1, 48 times 2, and then I keep adding 9 to each one because the formula says that you are supposed to add k. So we have the 336, okay, so now plus another 48. So next one is 393. is 441. $15, 1 5. Okay. Oh, 150. I quit.
I heard you say 50. I was like, Jesus.
No. Okay, so let's talk about the whole procedure one more time. So the steps to find systematic random sampling is take the population. In our case, all of the students who signed up for algebra or statistics or whatever in the whole school would be 728 students. We do not want to do 728 surveys. We want just a sample of 15. Now you are not going to go and pick 15 students that belong to the same classroom because, why? Why would it be bad if we want to survey all statistics students? Can you give me one reason? Why would it be bad to select random 15 people from this room? So someone walks in and takes the entire sample of all RVCC students in this classroom. Why?
The sample may not be diverse.
Yeah, but look, I mean, they can pick, it's going to be still random in this room, right? Take a random number generator and pick 15 students from this room. What could go wrong? What could be misrepresented? Let's see. Yeah, but in which way? I mean, specifically. Yes, but what specifically? Like, it's not going to be gender, definitely, right? That's not going to be misrepresented if you pick 15 people from here. So that's good. What could be misrepresented if you pick 15?
Older people more bias.
So you think, okay, so you think adults might have, okay, that could be one, sure. What else? Just give me one more, I'll be happy. So sure, we'll keep going. Major. All right, well, I'll give you another one. High school students. We have a lot of students who are in high school and they're taking RVCC classes. They can't take classes while they're still in high school unless their program is academy, which allows them to take courses, but they have it's a cohort that moves, so it's a special stats class that they will enroll in and so on. So there are a number of reasons why you don't want to pick, one class. Now, as you can see, the sample size is 15. We do have 15 numbers, and note the way I organize these numbers. Obviously, smallest to largest, as I was calculating, I was writing them down, but I also put 3 rows of 5. It's visually easier to look at the data, and you can see that you have sample 15. I knew visually when to stop. Well, clearly the other number, when you add 48 and 9 to this one, would go over 728. So you can see that the numbers are between 1 and 728. And if you go one more, if you go one extra, it will go over the population number, it will be bad. So we round it down to keep it within the bounds of 728. If you round up, then the last number might jump over 728 in your calculations. So we have to round down, then we pick a random number in that range. That's our starting point. So this plus 48 plus 9. plus another 48 plus 9, plus another 48 plus 9, and you keep going like that all the way to the end. So that's the systematic random sampling, and again, it's a procedure. You learn the procedure, and that's it. Now, the next procedure would be the cluster sampling. Again, 3 steps. Step 1, divide the population into groups. Those groups are known as clusters. Step 2, obtain a simple random sample of each cluster.
Professor, I have
Mm-hmm.
a question. For the first one,
Yes.
to generate it, how are we going to do that on the exam? Just go into Google or we can do it on the calculator?
How are you going to generate the
Yeah, for step.
from the list of random numbers?
Yeah.
The table, right? Yes.
Will we make one of those, or will there be one on the exam?
There will be one on the exam. It's good. What was I talking about? Oh yeah, obtain a simple random sample of the clusters. And finally, step 3, use all the members of the clusters. From step 2. I hope you see that this would be good for, surveys in terms of if you have to go into like door to door or something like that, because you have, let's say, a whole neighborhood of apartments and a neighborhood of houses and a neighborhood of, right? So you can divide your population looking at and call those clusters. So there is, let's say, a complex of 6 apartment buildings, and then there is a little strip mall, and then there is a neighborhood of, let's say, 100 houses, right? So each one of those could be a cluster, and you use the simple random sampling to make samples from each of those clusters, and then you just use all of the members of each one of the cluster. So let's take a look at the example. So population is 300. What happened?
Oh.
Population is 300. So population is 300. People, rabbits, I don't care what it is. It's just population is 300. And then we want to create clusters of 20. So divide into clusters of size 20. So if you look at this, right, you actually have now 15 clusters. So I'm just going to put that in parentheses. There are 15 clusters. This should be clear because 15 times 20 is 300. So if you start with 300 and you want 20 clusters, so each cluster, if you divide it evenly, it's going to have, so each each cluster of size 20, and there will be 15 clusters. There we go. So now what we do is we realize that, I'm not going to write all of them out, but so cluster 1 is 1 through 20. 2 is 21 through 40. No, 40. And then we go this way. Cluster 3, 41 to 60. So these are our clusters, right? Cluster 4, 61 through 80. Cluster 5, 81 to 100. And I'm just going to put 3 dots. Cluster 15 is going to be 281 to 300. And there's the lag again. Great. So the network is moody in this classroom. Yeah, it says I'm connected. It's just poor signal. All right, so now I am going to either use the number table, random numbers from the table, or I'm going to ask Google to give me a random number for each cluster, and there's my sample of 15. I can come up with a larger sample if I pick 2 random numbers for each cluster or more. Yeah, the blue screen of death. Let's make. Now you pick, and now. Okay, it's gonna get soon. There we go. Connect. I'm going to use, so maybe this way, say, use random generator on each cluster. So we're using random number generator on each cluster. And that will give us, so I'm going to go to Google and ask it to give me a random number 1 to 20.
You want us to do that for all 15 clusters?
No, this is just an example. On the homework, obviously, you will enjoy your calculations. So Google gave me 7 for the first one. Then I'm going to ask Google to give me 21 to 40. It gave me 23. Then I'm going to ask it to give me 41 through 60. It gives me 58. And now the random number from, so each number comes from a different cluster. However, guys, you can pick 2 random numbers or 3 random numbers, depending on what is the sample size that you're looking for. So next one is 70, and so on. There will be 15 numbers because I was 15 data points because I was looking for one random number generated from each cluster. Now, you can go and do the random, right, 2 or 3, and then it would be the number of clusters times how many you have per cluster. So if you go with 3 per cluster, what is your sample size?
100.
How many clusters do you have? And you take 3 numbers per cluster.
45.
45. You have 15 clusters. 3 numbers per cluster is going to end up being 45 numbers. And that takes care of that clustering. There are other techniques as well, multi-stage sampling and so on. These two are the ones that are the main ones, so focus on these two. Make sure you know both procedures so that you can perform. And also, make sure that you can pick, random numbers. So on the exam, I mean, that's something that I can't really grade, whether you just looked at it and said, I like number 9, or you actually did this, which you're supposed to do. You close your eyes and you just poke into a number somewhere and say, okay, I start with number 7 and go on from there. That's it. I hope you're not disappointed. So we're just going to say bye, right?